right? So I'll be presenting the data analytics at Logitech. It's not so much about just Tableau. It's more about an end-to-end solution architecture. How do you get successful in ensuring a data platform that scales for business, and while at it, it ensures the performance, making sure it's cheaper, efficient to get to that data. Well, that's me. Probably looks the same. I'm all of those. I'm engineer by education. I've been designing databases for a while, different technologies all over, done every flavor of database that exists. And here we are on more cutting edge at this point of time. Well, enough about me. I think you could find all of the data on Facebook. What is Logitech? Most of you possibly know Logitech as the peripheral company, keyboards, mice. Don't know anything beyond. But Logitech has a lot of verticals. We make custom headphones as an Ultimate Ears Pro, to Jaybird, to Astro Gaming. Recent one is Blue, the professional mics. We make security cameras. So the reason I'm bringing those up is you'll kind of see where we are in our data journey, right? A keyboard mice might have been a peripheral that you buy, forget about it. There's no data that's coming out. Things are changing. We are evolving even in that data platform where a mice which is connected is generating data, and we are looking at that information. So essentially, we moved from just the peripheral, which is about 10% of our business, to more digital experiences for every ecosystem that exists, right? We build the products which essentially are bringing families and people together. So that's sort of still a dated data portfolio from a product perspective. As you can see, we are in VC space. These are connected collaborative tools. We have connected home devices, as in Harmony platform, Circle cameras. Gaming is huge. This is PC peripheral gaming. And on the leftmost side, you can see all the connected productivity devices, like one of these that I have here. As you present using this clicker, we have data being ingested in near real time, right? It's not truly real time, but it's near real time. And then all of the music products. And there's always an augmentation of few more product offerings that come by. So with that in mind, the portfolio that we have on product, you can imagine the data spectrum to it. All of these are connected devices. Every time that you do an 8-hour-long VR gaming session to a presentation that I'm doing for an hour, is generating data. You could figure out the volume of data that generates from a gaming perspective. Every event that you do, every button click that you use in the gaming device to every clicker device here, the data is coming in. It's anonymous data, obviously, but we're looking at the semi-structured to unstructured data around it. With those portfolios come, I'll pause on this slide, but this is a slide I like to talk about. It kind of maps where is the data at. So you can see the velocity is from real time to a batch processing to all the way from structured to unstructured. And it kind of gives you a sense of everything that we have from a data ingestion perspective, where does it land in this metrics? And if you kind of build this metrics, you can figure out what kind of data platform you would need. How do you scale it? Do I need real-time ingestion to batch processing once a night, once a week? What kind of data I need to put in? Is it always a database where it's relational data? Do I need to go look at more JSON documents, Avro documents? Something is externally hosted data which I cannot control. Point of sale data that we use, no clue how would the platform be. There are new opportunities on getting to that data, but there's always that EDI interface which always existed in the past, right? So this slide would kind of give you a sense of how one would approach a solution architecture into it, right? So you could see we just saw in the keynote, the NLP is huge. We've been using that for some time now. Now I have some offerings. Maybe it gets redundant with Tableau's offering, but we already have something like that. We have IoT around all our connected devices. We get all the data in real time. Obviously, we do sentiment analysis on those. We are a B2B company, but we build consumer electronic goods. So we absolutely need to know that somebody who won a Logitech product at a conference, he goes back and sells it on Amazon for half the price. It's one-off, which we would know, but if somebody finds a pallet full of those products, I'm losing revenue. So I need to know around price violations that happen. Somebody from Japan sells a product on Amazon US. I need to know about those because there are price differences on different things. They are illegal to be sold in a region across regions, right? So things like that need to be acted on. It cannot be 1 month down the line that I need to know that information, right? On the rightmost is the VR gaming. We have our peripherals getting into the HTC platform. So if you are playing a strategic game, the keyboard sort of shows up in there. I'm capturing every keystroke that you use, so we could make the peripheral more efficient. So it's more engineering side to it, but we also get how many people use the platforms, what's the depth of those penetration in the gaming industry. All of our devices in the Harmony platform are connected. We know anonymously that this device is being used to watch ESPN. So as a product offering, we improve the product saying, 80% people love ESPN during this NFL season, so there's a button which will say NBA TV, right? So it's just going to go there, NFL, ESPN kind of thing. So it improves, it's continuous improvement process based on the data platforms to it. And then the leftmost is our traditional data platforms. Data warehousing obviously is there. We have multiple ERP implementations. You have to demand forecast for all of the products. So we do 52 weeks forecasting every Wednesday of the week for next 52 weeks, right? So that's more statistical forecasts, adjusted forecasts, and then the actuals come by. All that needs to happen. So in the past, the process used to be 3 days to just do the forecasting. It was an R algorithm. Today, with the power of the platform, we harness that speed to deliver. It takes less than an hour to do the 52-week thing. And then you obviously see some of the marketing platform implementations. Well, so why are we here, right? So that's sort of a very high level. Why do we need a good, robust platform to ensure the data analysis that people need is available? So we were on traditional Oracle Teradata implementations. We couldn't scale beyond certain things. It's essentially a chaos, right? If you see, and I'm hoping a lot of you can resonate with this. This does happen in a lot of industries. That's what we were at. To move ahead with the data demands that we have, we essentially needed something which would take us to the next level. Make it cheaper, faster, efficient, and self-served. So what did we do? Essentially, we looked at data platform that exists on the planet. We're still a traditional enterprise, right? So it takes a while to get to new technology. It's going to actually take you some cycles to ensure everybody is kosher about the platform that we go with. So when we were looking at reinventing what we went to get to from the whole traditional Oracle on-prem implementation of all reporting tools, few things that came up. It has to be a cloud footprint. It needs to be cheaper than what it is. It cannot be a data dumping ground. People need to get to that data in real time and ensure that they can analyze it and not take the data and prep it beyond and then use it. So it was more of connecting with business at hip and ensuring we are successful in real-time ingestion. And with that came all of these delivery demands. It's no longer a traditional way of looking at information. No Excel sheets need to be taken off from the platform and massaged and used. We want all business folks to come to the data platform and be enabled for it. So whether you use R, Python for data science, or using Excel for reporting, or Tableaus of the world, you still need to ensure that you're getting to one single point of touch to get the data. Well, so we all know why cloud. For us, it was a big deal. We didn't do anything other than on-prem in the past, right? So right from reinventing what does the security mean to us, how do you make sure you are not doing everything in your availability zones? Can I be more efficient on figuring out what are the options that are available? We looked at all the cloud providers. We went with AWS, just the fact that we can have an extension of our own intranet and do all implementation. This is just high level. We wanted to ensure we only pay for what we use. Infrastructure needs to be flexible. So Tableau on Linux is a big welcome because on AWS, Windows would cost you 3 times of Linux. So we push for implementing everything on Linux in that ecosystem. Obviously managed, so the traditional roles that we needed of sysadmins, a DBA kind of thing, are shifted a little bit. They still are needed as bodies on, but they reinvent. They're not more of taking backups and things like that. It's more self-governed, self-oiled process. The other thing we did was, in the past, we had always seen people, business users trolling the database, right? So you have a database, you expose it to Tableau, for example. They would go in the schemas and start looking at what exists there, what objects exist there. They see a familiar name on a table, they start using it, right? So now you lost the whole governance mechanism around it because there's no way you can deprecate anything or change anything because you have no clue who is using what and for what purpose. It just showed an inventory in the name of the table doesn't mean it's meant for certain, right? The business rules around that object need to be known before you start using it. So what we did was sort of demarcate a business layer from the data layer. And that comes with a data virtualization piece where we needed a single semantic repository. It should be optimized. We wanted to enable sandboxing concepts to it where people could quickly build a model, not wait for a whole pipeline to be built and bringing the data in like 6 weeks or 8 weeks or whatever it takes to build that into the data warehouse. You could quickly get to a data from connections and play with it, and then if it's truly meant to be, then you can push it in the right stream of things. We have a single security layer, which is governed and centralized. So if you can kind of look at these benefits, the reason for this is you can get to an enterprise data layer, which is a single repository of objects. So now, with this implementation on top of the warehouse, we are essentially tool agnostic. If I'm writing a code, I'm good at R or Python, I'm writing an algorithm there, I'm getting to the business object to query, let's say sales orders, for example, and I'm building a model on top. In the traditional sense, somebody else might build a Tableau workbook on the same data set from the database, but they might change the rules or they might use different joins. I know Tableau is making easier the joins and stuff like that, but till today it's not, right? So if I do a write auto join in Tableau, my results don't match with my R and Python code, right? With this governed layer, you are, no matter whether you use Tableau, R, Python, whatever, you are actually coming to the same enterprise entity, which is sort of a definition of a governed object, which has a data catalog, business glossary attached to it. You could do what-if analysis, saying if something changes in this data object, what's the impact? Which all of your books would get impacted, what all code would get impacted, and you can get to that information. I'll just put these here. I think most of you would have gone through that pain. They're always there from all business users. We, as sort of the data platform stewards, have to always listen to these. And this were reality at Logitech as well. We are a global reporting. There's no windows where you could do sort of a downtimes and things like that. You've got to be 24 hours, 24/7 up and running. So the way we implemented was Snowflake, like I showed you, was the platform of choice. How do I make these things happen, right? No zero downtime, but we flex up the compute. So come Monday morning when everybody wants their reports, all upper management dashboards in the hallway need to be refreshed and things like that. We actually bump up the compute on the fly, get those up and running, and then kind of as needed, reduce the powers, right? So we're elastic on how we use it and pay for it. That's another one where people are looking at, I want all 7 years of data. I mean, you couldn't control who needs what. In today's era, we want to have more and more data made available to business users, but scaling that to a few billion rows of data and putting Tableau on top of it would be a challenge, right? So we want to make sure no matter which tool you use, I want to make sure I can scale the needs of the hour. So we essentially have been successfully pushing all of these pain points. And it takes some brainstorming with business users saying, what are your top 5? I mean, you obviously cannot reinvent the whole thing, right? So you got to take first 5 in terms of pain points, first 5 or 10 queries, which are the most long-running analysis, tackle those, go to the next. So we also have an iterative process to kind of improve the performance on the platform as we go along the journey. Sort of similar how we do it. Obviously, Tableau has a caching mechanism, but the data velocity is different for different requirements. So we want to ensure we can scale the data platform to get to that information as soon as possible. That's a new for us. I think we always had this data with us, JSON, Avro, semi-structured data. People didn't do too much with it. The data existed in the ecosystem, but we never actively worked on it as a proactive analysis of it, saying, do I know who all own multiple verticals of Logitech? Can I have opportunities to go about selling, cross-selling, upselling of products? If you are on my Harmony platform, can I tell you to go look at the circle cams, so conversions happen, right? Things like that. They all treated themselves as a vertical within the organization. So what we're trying to do is go horizontal to ensure not just the marketing insight, but also look at engineering reusability. If we have a feature in one of the hardware, can I reuse it to something else, right? I mean, the sort of convergence where you could have reusable code and things like that. So today we traditionally store the data in Snowflake. We ingest real-time data from the devices, and we store them as JSON files, right? So you could actually query a JSON document natively from Snowflake. So instead of doing it on S3 and trying to use something like an Athena or Redshift Spectrum combination, we just ingest that in real time. The moment it hits S3, we are using a capability called Snowpipe, which ingests the data real time into Snowflake. And we keep it at that. Obviously, for Tableau to work, we have to create some business objects on top of it. So we could flatten out certain of those components as the needs are. But from a SQL interface, you could go and directly access those files in JSON format itself. So this was one of the issues. We ingest 1 billion rows of machine data every day at this point of time. The hardware that it has been enabled is only 6 or 7 devices worldwide. And we are hoping to get to every equipment that we sell or every product that's on the market will be a connected device. So we are looking at 50-fold increase in the data ingestion. With 5 of them, it's about 1 billion rows. And it's not all the events as well. So as people start looking at the information, the need for more and more events will come by. So that essentially goes horizontally scaled, and then with the more equipment enabled, it will be more vertical growth. So 50-fold, I think it's still on conservative side. We need to gear our data platform. Come that time, I don't want to redesign that on our team. We need to ensure we are able to get to it near real time as the data is made available. So how do we do this? So that's our data warehousing solution architecture, left to right. Just have few sources there, but there are a whole slew of them. Exadata is our EBS system as of today, on-prem implementation. We use Salesforce, Google Analytics, Adobe Analytics, Facebook Business, because some verticals are not on all of enterprise platforms, so they use everything in the cloud depending on where that company was acquired from or how big is that footprint look like. When you move to cloud, there are fundamental differences on how your ingestion pipelines need to change. And you should always design the architecture for the worst case scenario. I mean, you might have a big fat pipeline going to AWS, so you could stream data over internet to AWS. But for me, I'm looking at something that would scale even if my pipeline is really bad, right? And this is the worst case scenario where you no longer do synchronous processing of information. You would split that into components where you take data from on-prem or other clouds into the cloud. At its own frequency, that's the data producer up there. It runs at its own frequency. The starting point is a source system and endpoint is, in this case, S3. So sort of a data lake perspective, take the data, touch and take mentality, and at its own frequency, the data producer is generating data. And it has no bearing or no knowledge of something who's going to consume that information, right? So you take data from on-prem to cloud, at its own frequency, let it run, and then comes the consumer, one or more consumers. So you produce once, consume multiple times. Consumer's job is to get the data from S3, take it to the data warehouse. It runs on its own frequency. It has no bearing on if there is any data available or not. It's going to go look at the S3 bucket. If there's data, it will ingest. If there's no data, it will just come out of it, right? So you are producing data at its own frequency, consuming it on a different frequency. You could consume multiple times based on its own consumers. So you could create regional data warehouses. So now it kind of opens up opportunities for different implementations. So you produce once, consume multiple times. So out there in Snowflake, we have our data warehouse. Beyond that, and you could see none of these tools are still looking at Snowflake directly. The business layer architecture, which is the data virtualization piece, it has a few components to it. It takes care of all the security there. We have data cataloging, business glossary being implemented at platform. If you see on the top is the business rules, where it says how should the objects be joined, which Tableau just presented, but we take care of that. We don't want the business users to guess what the join should be, because we as data stewards know when the data is ingested in, what's the data integrity of it. If there are default values need to put in, all that is sort of done in the pipelines as the data is ingested, right? So we know exactly if it's an inner join, it should be inner join all the time. So we don't want people to guess. Typically Tableau, everybody does a left or join just to be safe. And it's bearing on the SQL that it generates. I mean, these tools are not the best SQL tools. They generate cryptic SQL, and it's hard to make them scale. The last piece on this platform is those joins. And if you see the arrows coming in real time, I can get data from Snowflake warehouse and Salesforce, blend it there, and provision for business consumption. Now, what does it do for me is I could do sandboxing out there, and it's sort of the concept which Google did, right? You push down your code to the data. If I have to pull 1 billion rows from Salesforce and ingest it and store it, I'm adding some latency to that information. If I push my query to Salesforce in real time, within the constraints of what their API allows, I'm actually able to do real-time analysis on Salesforce or Google Analytics or Facebook and things like that. Whichever APIs are open for consumption from a data perspective, you could do something like a MapReduce concept to it, right? So you push, when we run a query from here, it actually goes to those sources over the API. I mean, you cannot do a 7-year worth of query, but I can do creative ways saying, till yesterday, I want to cache the data here, and since yesterday midnight to right now, get it real time. So I'm real time querying information from those data platforms. So that's sort of the convergence that happens in business layer. So it's augmenting your data warehouse to give you insight to something that's existing in different cloud processes. It also allows you to cache the data on that platform, okay? So with that implementation, we are actually tool agnostic. If I use R, Tableau, Python, anything else, we are actually using the same business entity objects that are governed and secured. Just a little twist on the IoT side too. So it's an edge compute. Things don't change too much on the right spectrum of it, but the edge compute as it happens. Today we do some custom C++ code that's been implemented. So if you have Logitech mice, you will see something installed called options on your laptop. Essentially, that software allows you to manage your preferences for the product, but it also has a data push mechanism. Eventually, we would want to see something like an Kafka or Kinesis, which is more shifting away from traditional implementations of edge compute, right? So we go to that. I talked about Snowpipe. For this case, it's insert-only data. It's semi-structured, but you never update events, right? You will keep on getting new events coming in from the pipeline. So we use Snowpipe, which is real-time ingestion. The moment it uses SQS functionality on AWS, the moment a file lands in S3 bucket, it gets sucked in. And it's massive parallelism, so we actually provision the data in near real time into Snowflake, and we store that in JSON format itself, which has allowed folks to look at that information as it is coming in. So if there is lag in the edge compute, possibly a lag in your reporting, but if, let's say, Kafka messaging is proven and it's working the way we intended, we would actually be able to query those data in real time, and the hope is you could act on it. So If an equipment is not connecting to Bluetooth for whatever reason, we should be able to fix it in real time, near real time, and send back something as a signal. Because these are connected devices. Like today, what Tesla does would be what we would want to do for our products. And then you still have a Tableau or Spark working on those, and you could create specific views for reporting. So we've been pushing to use Spark on top of Snowflake rather than on S3 to take away all the pain of, take away all the pain of putting schemas together, ensuring you could scale the buckets and stuff, or using Athena and adding partitions. So it's just getting it easier to get to that information, and most of us are SQL savvy, so it kind of helps get to that SQL procedure. So that's sort of a benchmark I recently did for the IoT data. As you can see, we ran multiple versions of a Snowflake warehouses to see how do I scale, what's the optimal performance to cost ratio that I can get to. We were on a Redshift piece for this IoT data that I was talking about, real-time ingestion. So pipelines which are reactive, data brought in to Redshift and put on queries, and a tool called Metabase was being used. Eventually we will move to Snowflake and Tableau on top, but as you can see, same queries, same volume of data. That's sort of the query execution time. And there's no reason for a business user to wait for that report to even show up, right? As if you can see. And we did a whole spectrum of different products, variations, complexity, maybe a full scan of all the records that we have in the database as of today. Just a simple, I want you guys to look at the gray part to it, right? So the same query, little syntactical, but that's Redshift to Snowflake. It's a clustered base because it's JSON data and insert only, so you kind of do an auto clustering on that. But you can see the pricing out there. And it's a simple formula. I mean, depends on, I don't think we are on the cheapest of Snowflake version, we early adopters, but that's sort of looking at it. So now you give business an option saying, am I willing to pay that to get that performance? Or, it's like an a la carte now. I can say, this dashboard needs to be in front of the CTO and needs to be super fast. I'm willing to pay more, but come out of it faster. Or there is more exhaustive analysis, which we are okay to do. So essentially, with the cloud, you make a call of how much am I willing to pay for what performance. And this is essentially our own experience. Like I said, we were on Redshift in production payloads for an year, and we moved off. I was questioned because I was also solution architecture for that. And why now, right? Didn't you tell us to go to this technology and then you're moving off of it? I'm told not to put the name up there, so it just says columnar DB, but bear with me, right? The basic challenges, right, is the architecture, fundamental architecture to it. It is not shared data. Every node in that technology has its own data. So the moment, and you could distribute data with only one key. So we said, most of our analysis is product-based, so let's partition everything on product. And here comes queries with customer-based analysis, and it starts broadcasting across the nodes. So it's even worse, if you have broadcasting going on, it's even worse than a traditional relational performance, right? And things fall apart pretty fast. In self-service mode, you never know what the queries from business users look like. What would Tableau put as filters, predicates on the queries? I don't know. I mean, it changes every time. It's very dynamic nature to it. So Redshift would have you put sorting at the DDL level when you create the objects, which makes it really hard to design. And for performance to scale, you need to understand what encoding is. Most of us who are database developers have never had to deal with that in the past. So unless you are really geeky, understanding what is LZO compared to a small int, how does it compress and stores, that's very hard to design on those. So all those pain points essentially were taken away. Now we could natively support all the JSON files. We created multiple warehouses. Today we run about 8 or 10 warehouses in production for different business usages, but the data is all stored, right? And it's shared across. So could quickly scale a new business and put them on there. We also know how much it costs us to to support that business, and they also get better performance. So there's no contention of resources across warehouses. Then came along this more academic discussions, right? Why can't I query S3 data? Why can't I use what's natively available on AWS? And the answer is yes, you can, but at what cost? And what do I get out of it? Yes, if you are a small company, one data scientist doing everything, maybe. If it's an enterprise where we need to eventually scale everything, I would hate for them to throw away what they build on Athena and say, now you go rebuild it on your platform. Because as you can see, the cost with Athena in itself would be a challenge where if you and I run the same query, the volume of data that comes out, we are paying for those each inbound thing, right? Which is not true with this. So we actually had those built in. Schema was the biggest challenge because the files kept on changing. People add new events, and the schema is broken, right? So there was no way, with our limited team members, we could scale beyond a certain point to keep on adding those things. So we actually got rid of that and moved those payloads as well to Snowflake. Spark obviously was the next one. Spark is kind of, a lot of documentation around, there's a school of thought around how Spark should be done. I think a mix of a SQL engine along with Spark makes it to scale better. In our experience, there's some benchmarking which is done by third party, which talks about why Spark with SQL interface works faster on Snowflake, because they could massively push down the queries and things like that. These are just high level why you would go using Spark on Snowflake. We are still dribbling. There are some lingering Spark implementations with S3, but the hope is we are converged on the whole data platform as single implementation. We are also looking at, instead of Spark EMR, which is always up and running and you pay for it, to go somewhere, a SaaS vendor, which allows us to get the elasticity on Spark as well. Just some of the key features that I think helped us, and maybe you guys, it's a takeaway. The time travel was a big one on Snowflake side. It's sort of a slider mechanism, but with a SQL interface on a query language, you can say, give me a snapshot the way it was a week back or 90 days back. So let me see what was my sales order revenue 90 days back. Because they store data in S3 and a mechanism to get to it, think about it like a pointer in time, they can go back in history and just give you that snapshot of it, which is very hard. Like in Tableau, if you do year-over-year analysis, you guys know the pain of it, right? How to build it. This would hopefully make that easier to get that information. We are playing with data sharing. We are traditional EDI, but we are looking at some partners who might be on the similar platform where I don't need to get EDI files, email files attached with POS data. If I could just get a data sharing up and running, so we could share their data into which is our external data, but now we can extend our Snowflake and their Snowflake to kind of converge somewhere with the data platform. We talked about the auto scaling piece that we absolutely use. And like I said, the traditional backups and stuff is no longer needed. So we kind of moved away from all those things. We quickly clone an environment, bring it up as a sandbox, and start using it. When we don't need it, we just shut it down. We also have a setup where even in production, for no activity for 5 minutes, the warehouse goes down. So we don't pay for anything. And next query that hits, whether it's Tableau or whatnot, it brings it up. So we want to make sure we are not paying the way we were paying on Redshift or on perpetual licensing. We absolutely, every environment is 5 minutes, so no activity, it goes down. And this is sort of the data virtualization piece. What we do is we create sort of a big data platform where, as you can see, there are a lot of external services, internal services being exposed through the data virtualization layer for regular dashboarding, but as well for advanced analytics piece to it. So that is sort of, you'll see Snowflake Warehouse as a part of that ecosystem. So we scale beyond and get more and more data offerings instead of building everything as pipelines. I mean, you could pick and choose depending on the service, but it allows you to get to that data real fast. And then, based on the solution architecture, we really had good feedback. Business is really happy. Everything that they had to struggle for in the past is right there. So it's working fine. And then comes, brilliant minds start thinking more and more what they can do. So something like this is sort of an afternoon thought process, think tank kind of thing, where we said, let's try something beyond that. I want to go more real time, maybe opportunities of getting to the information in a different perspective. So I wrote like a chat bot, which essentially asks you a Slack form. It will ask you 3 questions, sends it out in real time. It goes to our NLP engine. The NLP engine will seek out some data based on what you're looking for and get you back the narrative, and it sends it back to you in Slack. Not fully deployed in production. This is something I actually also built at AWS Hackathon. The intent is, what can you do beyond with the data platform, right? Creative ways of getting the information. I actually wrote an Alexa code on top there. So you talk to Alexa, it converts the voice to text, goes through this pipeline, gets it back, and Alexa talks back to you, right? So these are some of the creative ways that you can go beyond the data platform. Logitech makes the boom speakers, which are Alexa enabled. Why not provision them for different business communities? Sometimes salespeople have specific questions. Why would they go to even a dashboard and narrow down and filter and things like that? Why could we not enable something like that? Okay. So these are more advanced use cases. As things streamline, everyday work is like a bliss. You start thinking more creative ways. We saw just now in the keynote they presented a fuzzy query engine. We actually have this in production today. Might have to deprecate it if Tableau picks up, but essentially this is just English language where we want everybody, every user who is not even SQL savvy, Tableau savvy, to get the answers they are seeking, right? So it essentially says, what is my forecast for this in EMEA? And it essentially translates that English to SQL, goes on the data platform, gets you back. And this is browser-based, so it better be fast to get to that answer. I mean, sometimes maybe it's a lot of data on tabular, but still gets you the information that you're looking for. So that's sort of the power of data platform. I haven't talked anything Tableau, so let me put something that we do. I don't want to do a demo. I don't think the demo gods are really happy with me, but we'll kind of look at it. So we started our own user group. We have a huge community of Tableau users across the globe. Was really good. Yeah, my colleague is not here, but Suresh is here. So we started this training thing, like train the trainer and all those things. We cannot send everybody to a Tableau training. We just 3 of us here from Logitech for Tableau conference. So you can imagine, I think, Apple, I don't know, 100 people. So you can see where we are coming from. So, but we want to be successful at looking at that. And while we're doing trainings, we track some of the performance piece to it. We absolutely, from a data platform perspective, want to be ensuring that the operations is streamlined. I always question Tableau community to show me bad queries being generated, right? Because it's adapter-based. So depending on the driver that you're using on Tableau, it will generate a SQL, and it does weird stuff sometimes. Most of the time it scales. That's why all the hyper and everything saying, bring the data. We took away all the Tableau extracts. We had 300 plus, I think we have like a few now. But we want to make sure we don't spend that back office work to build those extracts and just a waste of time. And somebody from Tableau says it's milliseconds, but nobody sees that 2 hours that it took. And come Monday morning, most of the time it fails, right? So I'm up Sunday night working on it, and I don't want to do it. I want to move away from all those. So sort of these saying, did somebody mess up? Are we having lazy Tableau developers where they just pick date 1 minus date 2 instead of using the date functions, which is true ANSI SQL, right? So it's an education process. We want to not do finger pointing, but we also make sure a dashboard comes up there which shows some of those things upfront in the self-service mode. I talked about external pricing. This is one of the dashboards that all of our salespeople look at. How are we trending with competitors for our products? How many times do I lose my buy button on Amazon? Am I losing too much revenue because of certain things? Am I promotions on a totally different spectrum than they should be, right? So you could see we compare all third party, new, old, and when it says Amazon, essentially that's Logitech being selling those products, right? So this is something that people look at, act on it. If we see something below the threshold, there is something going on. If it's one-off, like I said, somebody won some and they're trying to sell it, it'll probably go off the market. But if you are having a quantity of 500, there's something fundamentally wrong somewhere. Point of sale is huge for B2B. As you guys know, all the Walmarts and Apples of the world are essentially working on these. What am I doing in point of sale data to go beyond to next step and sell more, right? So pretty exhaustive, a lot of things going on here, and this is just one piece of it, the puzzle. The hope is to get this whole business process well aligned. So we need to know when we sell into the channel, how the channel is performing, what are the inventories in there, what's in transit in there. When the end consumer gets that product, am I able to ingest that data back in real time when they use it to kind of close that whole loop? So the intent is, now that we have streamlined the whole data platform to get to that point, is to close that loop beyond it. It's not just about selling and there. We want to make sure people are able to use those products. Is the life cycle of that an year, 2 years, or is just 6 months, right? Do people just throw away the speaker after 6 months? Then we are doing something fundamentally wrong. So things like that would be the next step. We want to know exactly the voice of customer. We want to see what people are saying about our products. Some of them might be made up reviews, but we still want to look at it. So we kind of filter out the noise, but we also have to make sure if we see a persistent message which says it just doesn't work, there's something wrong that engineering needs to know about it and maybe do like a customer study or something, go beyond it. So we actually have this dashboard up and running in the hallway, which shows us the sentiment around it. And again, you don't do it for all the products, but you make sure a high-value product is looking at it. But there are cases where they even did it for a $30 mouse, just to make sure that it's not selling. So what's the reason that it could be, right? All of the Logitech's cameras are connected cameras. It's essentially a truly IoT. The camera sends data directly to S3. And from my phone, I could actually go to the app. No matter where I am, it's going to give me a direct feed of live action. It does an accept of the whole day activity. It has some AI capabilities in there. Like if you have a cat or a dog who jumps in front of the camera, you don't want to get a text message every 2 minutes, right? So there's this activity filtering out, the noise filtering out, but an intruder shows up at the door, you want to know about it. So it's real-time texting. I can actually feel that on my phone. My home back in California is buzzing there. But that's what we want to get to, a real-time experience for our customers. And with this, you can imagine, I have 6 cameras. There are huge installations, different sites information. All that is coming in. We still need to know, me as a household, what's going on there, right? So I could correlate data from individual cameras which are directly connected to the cloud. It's kind of hard to read, but we put a different bend to it, saying, what are people talking about in terms of a word cloud, right? So the data is all there. I want to segment, slice by different mechanisms and try to get to that information as soon as possible. So we did a lot of work now going forward on the IoT data. So this is essentially the semi-structured data from devices. Right now it's at about 7 billion. And then we map it, where is sort of the clusters of information that's coming from. So this is, a craft is sort of a keyboard which is used by Photoshop users. It's geared with activities that if you guys are Photoshop users, it's built in onto the keyboard, right? So you can see the clusters of usage of that keyboard in certain areas in the world. It's kind of mapped. So if we need specific format of keyboards, based on these conversions, we could put some features, specifically formats for the keyboards to go out in sort of a design phase to see how can we get that cluster more darker and darker. And you can obviously, this is Tableau, so you could drill down further to see what's going on, what the action, live action is happening at that point of time. And with that, I'm open for any questions that you guys have. Well, I'm not sure how. Yes? Let me walk over. I couldn't hear you, sorry. So we do it in the virtualization layer of Denodo. That's right. Yeah.
Interesting. Okay,
Yeah.
thank you.
Oh, me get those. Oh, anybody wants, I have some discount coupons for Logitech, so if you guys, I just thought I'll make something happen. Yeah, go ahead. Yeah, yeah.
Yeah, one question.
Yeah.
You said that you're not using extracts anymore for Tableau, so is it all live connection?
That's right.
So how are you doing it with live connection if you're only accessing the data when you need it? So with Snowflake, right? Because you said that you're
Yeah, so Tableau will, so the data, the warehouse has an auto resume on it.
Oh,
So when the query hits, the first query,
yeah. Oh, okay.
yeah.
What is the timeline for when it comes back? Like, would there be a significant delay?
No. The first query can be little bit. So if you're really looking at the benchmark, little bit, but not huge. I mean, that was a concern absolutely we had.
What's your budget for a year
On Snowflake, right now it's, no, we really started with a small footprint, about like 20K on that for the NLP project. We bumped it up because we gave up Redshift, we shut down all the thing. Yeah. I have my business cards if you need. And then our burn rate is about 20K a month now, but all of the warehousing, and we do all point of sale, all sales and marketing, finance, the CTO office, IoT data, and way more. So our hope is everything is converged on that data platform. I don't want any silo Redshifts lingering around, no RDS databases, because ultimately it comes back to us to scale it, and I don't want to get into a situation. So we are sort of pushing in the self-serve. It was substantial. Now that people harness the power of what we have implemented, we see more requests to the advanced analytic piece, right? In the past, I think 2 years back, nobody really cared about looking at sentiment analysis per se, but now it's available, right? You don't have to wait for 3 days to get that information. So we see more creative ideas coming about, and that's why we did a self-serve saying, come to the platform, play with it, see what you come up with. Maybe we learn a few things from you guys, right? So business users are really savvy on that. And now that we are tool agnostic as well, if you don't like Tableau, I shouldn't be saying here, but if you don't, you could be a SQL guy as well, right? And you will exactly get the same results, which is huge, which was not possible in the past because people had data marts somewhere and the pipelines was all reactive data ingestion. So it takes a while to kind of sync up everything. So, and then it's like my numbers to your numbers. So depends who's presenting them, right? Well, the equipment needs to be enabled. That's engineering. So they put the options. We are geared to ingest the data. Right.
Would Snowflake be able to handle the amount that it's going to increase up to, or any other ingestion process?
I'm told it will. So what I did was I sort of wanted to break it. So I opened the pipeline of that whole bucket. It was 6 billion, and I wanted to see how much time the historical data. I just opened it up, right? So it does multi-threading of copying in here. It took a day and few hours to get the all 6 billion. So right now I'm happy, right? But we also did some creative ways saying, how would I scale beyond if I need to? So I wrote some Python code to mimic massive parallelism, right?
And what about something like Spark or something? Would that help with the ingestion process?
Possibly. I mean, I would look for Snowflake guys to add more capabilities, right? It's fairly new. I don't think it's still like used wide, but the hope is the nature of the technology would allow you to scale it, right? I mean, eventually you will have some messaging pushing data, and you'll have to augment certain things upfront.
6 billion.
Yeah.
So it took 1 day.
Yeah.
If you take it up to the number of
Yeah.
machines that you have.
Well, because I ingested history. Think about this way, right? A file hits S3, you will ingest it, right? So you'll never have this backlog. At get-go, yes. If you have an implementation from an older technology to move here, you'll have to catch up. But rest of it is SQS is in real time, right? The moment it hits S3, it will send you an intimation and Snowpipe will pick that up. So we actually are thinking less than a minute latency, because the file will come to S3 and Snowpipe will pick it up. So it's well documented.
So
Actually,
you've eliminated the extra step which was required before, which is a huge performance.
it's huge performance as well as getting the data in real time, right? Because the challenge has been, if you do ETL, ELT pipelines, you can only run certain payloads.
So you do it through Kafka, you mentioned, and Flume Kafka, you split it and you process it.
Yeah, but still, Kafka cannot handle huge, right? It is more for real-time messaging, a small micro packets coming in. So, yeah, so that's the hope. I want to change that C++ piece at the edge to more Kafka. We have C++ right now, so if you see on your laptops, you'll see C++ package called options. Hope is to go more robust technology from a messaging architecture.
So it looks like you're still controlling the process from kind of your end, what you give users. So feature engineering, cataloging, all these things.
Yeah.
So if people need some different aggregations, who does it? So you
Oh.
said you have a layer, so they have to ask you to.
Well, so we provision lowest grain of information. When you use Tableau, it always aggregates, right? So depending on what your query generates, it will be pushed down through that platform to Snowflake.
So you spend effort in getting the performance right, so no matter what aggregation you do through
Yes.
Tableau, it actually
Absolutely. Yeah. So
adjusts it rather than you pre-aggregate
No, we-
thinking through, because that's for me is
Actually,
like
we
two
don't-
different ways doing
yeah,
it.
we don't pre-aggregate anything at all. So there was a time when on Oracle side you had materialized views and all those things,
all those
right?
things. We
Yeah.
push
No,
effort
we don't.
And it's always you're behind.
Yeah.
what
No.
people
Yeah.
need.
So we don't do any pre-aggregations. I know Snowflake will have materialized views, but if you're talking about petabits of data, maybe. At this point of time, I don't see a need. The only piece we did was clustering. If you guys saw on the IoT data, clustering helps with performance. The performance was way better compared to Redshift, but with the clustering algorithm, which is auto clustering, it is even better, right? So when I didn't want to put it there, but when we moved from Redshift to this, our performance gain was about 40 to 65% over Redshift, and about $2 cheaper per hour on what we were doing there.
So with the Spark jobs, you writing back, or what would you
We-
use the Spark jobs?
Now we are writing back. Tableau has a connector now, but we are writing back. It's more for a persisted reporting. So the reporting, yeah.
Even
So
though you said the snapshotting, you can go back and do it
yeah,
like 90 days.
yeah. No, we don't do snapshotting per se. Spark is more of the analytical piece to it, right? Like you do R and Python for data science. So we do Monte Carlo simulations, and they have to write back. Similar thing is usage. We don't do Spark as a streaming tool. It's more of analytical piece. And again, you could always question whether you need Spark or SQL is fine enough. But some people are savvy Spark users, and I mean, you can't preach everybody, right? Saying, okay, try it out. So.